Alright guys, so no computer science class would be good unless we started with the discussion of algorithms. So let's talk about some algorithms. First off, an algorithm is a series of steps for solving a problem or carrying out a task. A programming algorithm is a set of steps that specify the underlying logic and structure for the statements in a computer program. A computer program is a set of instructions written in a programming language, such as Java, that performs a specific task when executed by a digital device. Now, you know that a computer is input, processing, and output. And anything that takes an input, does the right processing, and has output is considered a computer. When we talk about algorithms, we're talking about how we handle the processing of the computer instructions. Input applies to the inputs that a computer receives. If you're looking at like your car, the input could be tire pressure, the input could be oil level, the input could be road conditions. Maybe it has cameras that are checking for if somebody's like lane change assist or rear view cameras. Those are all inputs to the process. And output is how that computer tells you any information. So when you're like looking at a screen in your car and it tells you that you're about to hit something, that output, maybe a visual, an auditory sound, or the screen like changes color, that's the output that the computer is giving us. When we use the word finite, we're talking about a good algorithm that terminates after a certain number of steps. Most programs, you want to have them stop at a certain point. And a good algorithm is precise in that the steps are clear and unambiguous steps. So we speak with a lot of ambiguity, but computers can't handle ambiguity very well. So we want to make sure that our instructions are precise and that the output we get is the correct output. So a few years ago I was backing a car out of a parking lot and it kept screaming at me I was going to hit something, and it was actually seeing the shadow of the car because the way the sun was hitting the car. That algorithm was not producing the correct output. My car was effectively scared of its own shadow. We want to make sure our algorithms are doing the right things when we run them. Alright, so here's an example of an algorithm. Get the last number in a series, 10. Divide 10 by 2 to get a result. Add 10 plus 1 to get a sum. Multiply the result by the sum to produce a total. And in this case, the question is there input? There is input. Are the steps precise and unambiguous? Did the algorithm produce the correct output? And is there output? And in this case, there is, and so this is a good algorithm. All right. There are three ways we can select and create algorithms. One is using a standard algorithm. The second one is perform the task manually. And to give you an example of that, a few years ago I was working on a program and I wanted the computer to figure out something that the user already knew because I didn't want the user to have to retype that part of the program. And what I found out is it's much simpler to just have the user type it in. You know, making the task manual worked better than having the computer try to figure out for me. And the third way is just apply computational techniques, which is using computational thinking to find the problem, working through pattern identification and abstraction to figure it out, which we'll talk about in this module. So those are basically algorithms, and I did want to mention one more thing about algorithms. There are three kinds of algorithms. There is a sequence of algorithms, so a list of steps. There's a selection algorithm where you have like an if condition, and there's also an iteration where a algorithm runs again and again and again until a task is completed and then it exits the iteration. So we'll see you later on.